Hello and welcome to this class. Let's look at yet the third method, the third type of variation called the joint variation. Note this thing, please. Joint variation is a type of variation in mathematics where one quantity changes in direct proportion to the product of two or more other quantity. Joint variation is similar to direct variation, but here's the deception. For direct variation, you only have just x and y. Maybe x very directly as y, just two stuff. In joint variation, then you can have y very directly as what? As p and b, or y very directly as x, y, z, or perhaps y very directly as a, b, c. So for joint variation, it can be more than one quantity. So I'm saying that in joint variation, one quantity changes in direct proportion to the product of two or more quantity. So one quantity y very directly to two or more quantity like ABC or AB or XY. That's a concept. So that this one here, you apply the concept of still yet direct variation here. But mind you, here I'm going to be having several variables like X, Y, A, more than just one quantity. So for illustration, let's say I'm given that Z, right, varies jointly. Observe the word varies jointly as what? As two quantity. Let's say the quantity as what are x comma y, or I can still say that let's say I have z, right, varies jointly as x, y, a. Observe that in this case these are two quantity, here what? Three quantity. This becomes what? A joint variation. But for like that variation we did, we just did y very directly as x. This is a what? A simple one. But I have what? More than this is not just x and y, two quantity, x, y, a, three quantity here. So for something of this nature, so let's say I want to explain this first one. Let's say I'm given that z varies jointly as what? S, y. Normally what we know is that to take off this proportion sign, I'll have z equal to what? Kxy. That's the concept, that's all. Kxy, that's all. I can make k subject if I want to. From here, k will be equal to z over xy. So that's the concept behind for when you have two quantities. When you have two quantity xya, we said that z is jointly z varies jointly as xya. How do you solve this? It's easy. Z is equal to k, to take off this symbol, then have xya. Make k subject. So therefore k is equal to z over xya. This is like the concept behind joint variation. So for joint variation, note that one quantity is what? Is directly proportional to what? Two or more quantity. Please, that's your derivation. So I said note that it works like the concept of direct variation. So note that joint variation works like the concept of direct variation. All right, I will say this. Let's look at several examples and let's see how we can possibly evaluate problems of this nature. So example 1, please. Example 1. It says that, example 1, please, P varies directly as Q. Observe the word varies directly as Q. But mind you, it is not just a direct relation because of the a joint relation. Why? Observe. It says P varies directly as Q and inversely as the square of R. You can see I have P, Q, and R becomes 3 because what the a joint relation is. Alright, it says P varies directly as Q and inversely as the square of R, and Q equal to 40 when R is 25 and P is 2/5. Question A says find the formula connecting the variables. Question B says find R when Q is 8 and P is 2. It's easy. Let's start problem 1. Solution. It says that P, this P, it says P varies directly as what? As Q. This is the direct relation, right? And inversely, and that same P again is inversely 1 over inversely as what? Square of R. That's what? Square of R. R square of R, right? So I'm given that Q is 40. They give us Q as 40. They give us R as 25, and they give us P as 2/5. First, it that is simple. I can see P is directly proportional to what? Q. At the same time, P is inversely proportional to what? R squared. What do you do in this case? I'll join the two together. So of course that this is PP, so that becomes P. This symbol is the same. Put the symbol. Combine this and this becomes Q, right? That is proportional to what? 1 over what? R squared. So I'm saying I'm just combine it because we said there is refers to as what? A joint relation. You combine the two together. So if I combine the two, I'll have that P, Q times 1 is Q. So I have directly proportional to what? Q times 1 is what? Is Q over what? R squared. So just join these together. So I have Q times, observe, just join Q times 1 is Q, then R squared comes here. So this is like perhaps not yet done. This is P, right? So from here, P, all right, from there P will be equal to K. Is the constant. To eliminate the symbol, I'll use equal to K. I have what there? Q over R squared. So I have this. K times Q is KQ. So I have P equal to KQ over R squared. Let's try making K subject. Perhaps I can call this is my equation connecting P, Q, R together. As you can see, from this part here, let's try to make K subject and put in all these given values there, right? From here, there's an easy one here. K times 1 is what? Sorry, 1 times KQ is KQ equal to P times R squared is what? P R squared. From here, it's easy. Let's make K subject, divide by Q, divide by Q. So Q cancel Q. I'll have that K is equal to P R squared all over Q. But basically, I'm given some values here. So now K will be equal to what's P? P is 2/5 times R squared. What's R? That's 25 all squared all over what? Q. What's Q? That's 40. Alright, that's 40. What's K here? K should be equal to, if you press the calculator, you should have that K should be equal to 25/4 is K. So K is 25/4. Press the calculator very well. You should have this answer as K. So I've gotten K. Alright. It's going to say that, hold on. It said question A says Find the formula connecting the variable. So question A. It says now the formula connecting the variable is given as what? P equal to KQ all over R squared. I can leave it this way, it's still correct, but we know K. K is this, so I can put the value of K. So P is equal to 25 over 4Q all over there R squared. This is the equation connecting PQR. Next up, it says find R when Q is 8 and P is 2. So let's find R. Let's find R. That's question B. It says find R. R is unknown. When what? When Q is 8 and P is 2. It's easy. How is it easy? Go back to your equation. From there, I have that P equal to 25. Observe, it's easy. 25 times Q is 25Q. So I have 25Q straightforward. To save time, 25Q over 4, right? Divided by what? R squared. R squared. From here, I can multiply over 1. This time, this is what? PR squared equal to, this time, this is what? 25Q over 4. I want to make R stand alone. Divide by P. I'll divide everything here by what? By P. So this P can cancel this P. I'll now have R squared left. Alright, I'll have R squared left. So I'll have R squared. R squared is equal to what I have here. That's 25Q over 4, right? Divided by what? By P. By P. This can be broken down as, this is R squared equal to 25Q over 4 times what? Invisible 1 is here. So that becomes 1 over P. So R squared should be equal to 25Q times 1 is 25Q over what? 4P. Mind you, I'm asked to find R, not R squared. So if I take this square here, it becomes what? A square root. So R is equal to the square root of 25Q over 4P. I cannot put my value of P and Q now. So R now will be equal to the square root of 25 into what's your Q? That's 8 all over 4 into what's your P? That's 2. So I have this. Let's get R. Let's get the value of R. Let's get R. Let's get R. From here, R will be equal to the square root of, if I'm taking my calculator, if I'm to simplify this one here, I should have about 25. Yes. Yeah. Yeah. Of course, observe, I can see 25 into 8 over 2 times 4 is 8. Right? Is 8. From here, r is equal to root what? 8 can cancel 8. I'll have just 25 here. Therefore, r is equal to what? Is equal to 5. So this is how you solve this particular question. So that is done. All right. There's still example that I can solve here. But let me do this as assignment. Do this as assignment for me, please. Do this as assignment for me, please. I'll put your answer in the comment section. I'll reply you. Right? Do this for me, please. Given that x varies inversely as y and z varies inversely as a squared. Question A says, express z in terms of y if z equal to 5 when y equal to 8. Option B, find y when z is equal to 2. Leave your answer in short form. Let's do this together, please. Let's do this together. Example 2. Let's do this together, please. Example 2. It says that given that x varies inversely as y, so x varies inversely as y and y as y and z varies directly as x squared, and this same x varies directly as what? As x squared, right? Z varies directly as what? X squared. The next question A now says express z in terms of y. Question A says express z in terms of y. So I want to express z in terms of y. What do we know? Look up. Z, we know that z is that proportional to what? X squared. From here, z is that proportional to x squared means s is equal to. What's this x alone? X alone is 1 over y. So I have 1 over y next up all squared. So I have expressed z in terms of y. Right? From here, let's do the needful. From here, if I'm to proceed further, so I have that z, right? This one becomes equal to k into, by the way, if I'm to apply indices here, this should give 1 square over y squared. These indices. So this square affects the power and the power. So I write indices. From here, I'll have that z is equal to k times 1 square is what? Just ordinary k over, because 1 square is 1. 1 times k is k. I have what? The y square here. So I can call this one here the equation connecting z and y. So this is simply the equation connecting z and y. All right. By the way, let's get k, right? Yeah, because question A says express z in terms of y, right? If z is 5 and y is 8, so let's get k here. If I want to make k subject, from here k should be equal to over 1 is z. 1 times k is k, equal to z times y is z y squared. From here, k is from here, but they give us that z should be what? 5 and y to be 8. Let's put the 2 there. I'll have that k is equal to what z? That's 5 into what's y? That's 8 squared. From here, 5 into what? 64. 8 squared 64. Multiply the 2. K should be equal to 320. I think so. Yes, K is 320. So I've gotten the value of K as 320. So I've expressed Z in terms of Y, which is this equation here, and also I find K. Right? So question B says find Y when Z is 2. It's easy. Find Y when Z is 2. So just if you record the connection, and then we'll have that. So it says that find, question B says find Y when Z is equal to 2. And they say leave your answer in short form. Okay, no problem. From here, go back to your normal connection that says that Z is equal to what? K all over Y squared. I want to make I'm looking for Y. Just swap. Observe. Do your swapping. This Y, it becomes Y squared equal to what? K over Z. Just do your swapping, right? So I swapped. So I have this. Mind you, I'm not looking for Y squared. Just ordinary Y. So eliminate the square. I'll take the square root of both sides. So take the square root of both sides. In that case, what should I have? Alright, for me I should have that. So take the square root of both sides. Square root of Y squared equal to square root of KZ. K over Z. So I have these two there. So square will cancel out square roots. I'll have that Y is equal to square root of what? K over Z. What's K? K is 320. So Y is equal to square root of 320 is K over what's Z? Z is 2. So divide this, I shall have Y is equal to the square root, the square root of, if I divide 320 by 2, I shall have 160. This is my answer. But mind you, your answer should be in what? In surd form. So take it to surd. Y is equal to root 16 times 10 should give 160. Right? Separate this. I can have this become Y equal to what? Root 16 times root 10. If I multiply this, I'll have this. Multiply this, I'll have this. So it's like going backward, reversing. Right? It's still very much correct this way. So if you don't know how to, if you don't know the concept behind surd, I've done a video on surd, right? So I'll drop a link to that video in the description of this video to learn surd, right? So if you have watched our class on surd, you should know how this works. From here, this is Y is what's root 16? That's 4. This is 10, please. This is 10 times root 10. Therefore, Y is equal to what? 4 times root 10 is what? 4 root 10. So this is my final answer for Y. 4 root 10. 4 root 10 is in surd form. So this is how I solve this particular problem under joint variation. Let's look at the last variation called partial variation, and we are done with all this concept of variation. Next class we'll look at partial variation.